Hello, fourth graders. To start with today, I would like you to open up your math notebook to a new sheet of paper. Normally, when we do these videos, I have you open your practice book, but today I'm going to have you take notes on your math notebook. Pause this video until you have your math notebook and a pencil ready to go. Don't forget to label this math lesson Unit 2, Lesson 1 at the top of your page. In the picture in front of you, you see a couple different unit squares. So what I've just highlighted in red is called a unit square, and I've arranged these in something called an array. Now, an array is something you should be familiar with. It's a grouping of rows and columns, and we use arrays to talk about multiplication. So in this first section here, I have 3 columns, which are going down, and I have 2 rows, which are going across horizontally. When I arrange my unit squares into an array like this, I can push them together and create an area, or the space that is on the inside of my rectangle. In the second picture here, you can see that I can still count my squares. 1, 2, 3, 4, 5, and 6. I can tell that with 2 rows and 3 columns, the total amount of area, or how many squares are inside my square, is 6. Now, it's nice when they have it all drawn out for you in the second picture, but sometimes they're just going to give you the measurements like in this third picture here. So instead of having the actual squares, what they're saying here is that I have 2 rows and 3 columns, and I can multiply those two numbers, 2 times 3, to get 6. All I'm doing is I'm imagining that this is cut into 2 rows and 3 columns. Now, using multiplication to find the area is something that we're going to be practicing today. In front of you, you have a square that's represented by 3 centimeters and 4 centimeters. Now, I can multiply 3 times 4 to get my answer of the area, which is the inside of my box. That would mean 12 centimeters is my answer. What I'm really doing there is I'm saying there are 3 rows and 4 columns, and I can fit 12 total unit squares into the inside of my box. I can also switch that problem around. 4 and 3 centimeters. Now, my question is the area the same in this box as it is in this box? If I have 4 rows and 3 columns? The answer is yes. 3 times 4 is the same thing as 4 times 3. Each time I'm getting an area of 12 centimeters. That means that the inside is representing the same amount of space even though it's situated in a different way. When I flip my multiplication numbers around and I still get the same answer, that is represented by a rule called the commutative property. That rule tells me that I can flip my numbers around in multiplication and still get the same answer. When we're talking about multiplication, we use certain words when we're talking about numbers. I would like you guys to write the problem 3 times 4 equals 12 on your notebook. Then I want you to label each one of the numbers that you're multiplying together as factors. 3 and 4 are both factors. They're the numbers that we're multiplying together. Then I want you to label 12 as your product. When I multiply numbers together and I get a certain answer, that answer is called a product. As we start talking about multiplication this unit, we will use the terms factors and products very often, and you guys need to be familiar with those terms. Please pause this video, write out the multiplication problem, and label each one of the pieces. Then what I'd like you to do is I'd like you to draw the squares that are in front of you to represent the area or the inside that is being represented by this multiplication problem. Today, instead of working on your practice book pages, I'm going to be asking you to work on your homework pages, and I want to show you an example of the first one. You are welcome to get your homework packet out and do this with me, or you can just listen. So, numbers 1 and 2 are connected in that A up here is connected to A down here. So your first directions say, please label the sides of each rectangle. And the second directions say, write an equation representing the area of the rectangle shown. When you are labeling the rectangles, you need to count how many rows and columns are in each rectangle. And you do that by counting the jumps that you make. So let's start with the columns that are going to go down like this. I'm going to start with my pencil here, and I'm going to count how many jumps it takes me to get to the end of this row. Here we go. 1, 2, 3, 4. That took me 4 jumps, so I'm going to label that 4. Now I'm going to start in the same place, but this time I'm going to count how many rows I have. So let's count how many jumps. 1, 2, 3, 4, 5. I have 4 columns and 5 rows. How am I going to find the area of this rectangle? Well, I'm going to need to multiply 4 times 5 equals B. Now I know that 4 times 5 is 20. Now what I've done here is I've labeled the sides as they ask me to do in number 1, and I've actually already written my equation, so I'm going to put that on the line down here. 4 times 5 equals 20. The area of my first rectangle is 20. I'm going to be asking you to do this for your other rectangles, but be careful. These are getting pretty big. Don't forget to count your jumps. Let's do F together. I'm going to start right here, and I'm going to start counting the columns first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I've counted 20 columns. Now I'm going to count my rows, starting in the same place. 1, 2, 3, 4, 5. Wow, this is an awfully big number. I know to find my area, I need to multiply 20 times 5. I'm going to write that equation here, but I'm not sure if I can do 20 times 5 in my head. 20 is an awfully big number. I want to talk to you guys about a trick that I have using zeros and tens. In your math notebook, I would like you to write the 3 problems in front of you out on your notebook. Press pause until you have that written. Now that you have the 3 problems written, I would like to show you a little trick about what we can do when we're multiplying by tens in multiplication. If I'm looking at 3 times 10, it might be hard for me to do that in my head. What I'm going to do is I'm going to take away the 0 and I'm going to multiply 3 times 1. 3 times 1 is 3. In multiplication, if I take away a 0, once I'm done finding my answer, I'm going to add my 0 back in. Essentially what I'm saying is that I have 3 groups of 10. I'm adding those all up, 1, 2, 3, and just keeping my 0. I can do the same thing with a slightly larger number. I'm going to take away my zeros. Once again, I'm going to multiply 3 times 1, which is 3. This time I took away 2 zeros, so I need to add my 2 zeros back. 3 times 100 is 300. I can do the same thing with bigger numbers. I'm going to take away my 3 zeros. 3 times 1 is 3. I can add my 3 zeros back in. 3 times 1,000 is 300. Now, let's look at something that's a little more challenging. This time I'm not working with tens, hundreds, and thousands. I'm working with 4 times 3, and I'm adding zeros to my 3. I know that 4 times 3 is 12. But 4 times 30 is a little more challenging. We can use our same tens trick by taking away the 0, multiplying 4 times 3, which is 12, and then adding the 0 back in. 4 times 30 is 120. In the same way, I can solve 4 times 300. Taking away my zeros, 4 times 3 is 12. This time I took away 2 zeros, so I'm going to add 2 zeros back in. 4 times 300 is 12,000. I'd like you to pause this video and give these next two problems, or these next two sets of problems a try. 5 times 3 and 8 times 7. Be careful. You can take away all of the zeros in these problems, but you have to put them back once you get to your answer. Pause this video and give it a try. Now that you've given these problems a try, let's see how you did. 5 times 3 is 15. In this next problem, I see two zeros, a 0 in the 50 and a 0 in the 30. I'm going to get rid of those, and I'm going to multiply 5 times 3 to get 15. Now, since I've taken away 2 zeros, I'm going to add my 2 zeros back in. 50 times 30 is 1,500. In this next problem, you're going to take away 3 zeros, multiply 5 times 3, and add your 3 zeros back in. 8 times 7 is 56. If you took away the zeros and added them back in correctly, you should have gotten 560. And here was your challenge. In this one, you took away 5 zeros, which means, yes, fourth graders, you need to add in 5 zeros. 1, 2, 3, 4, 5. 800 times 7,000 is 5,600,000. Now that we've learned our special tens trick, we can go back to problem F on our homework, and we can solve it a lot more quickly. I'm going to take out my 0. 2 times 5 is 10. Now be careful. Even though 10 ends in a 0, I still had a 0 that I took away, so I need to add that back in. 20 times 5 is 100. Today, what I'd like you to do is I'd like you to finish page 37 in your homework packet. This is also on Schoology if you don't have your homework packet with you. Then you're going to use your hundreds. Make sure you're using your tens trick for 3, 4, and 5, and as you get to larger numbers for E and D in your rectangles.